So in this lecture I am going to discuss about keys in DBMS. See, this is one of the important concept in DBMS because when you go for the normalization concept, in that case the prerequisite is what you should know about keys as well as functional dependencies. So in this video I am going to discuss about keys, because once you got this concept very clearly and the functional dependency concept, then for you to grab the normalization concept it would be very easy, right? So now in this video we'll discuss first of all what is key, types of key, what is need of key, right? Now see, let us take this example. I'm taking this table, or you can say this relation, because I'm discussing about what? Basically RDBMS, Relational Database Management System, and there we are going to store the data in the form of relations or tables. So I'm taking a relation here, the name is student. You can say it is a table or relation, and having 4 columns. Name is the name of the columns is name, marks, department and course. So these are what? Attributes, or these are called fields. So these 4 are fields, and this 1 2 3 4 5 rows we have in this table. So these are called tuples, or you can say records. Fine. Now why we need a key in the DBMS? Now see, suppose here I want to access some data. In that case obviously you need some addressing, you need row address, column address, and after that I can get this value, right? Now here in this case, in the form of tables, when I'm going to store the data in DBMS, then each column is having name, so that is a plus point for us. So now if I say I want to access the column values having name marks, so the name is marks and I can get all the values. If I want to access the column values having name department, so I can access these values, right? But problem is what? Row is not having any name. Now if I want to access a particular record or particular row, in that case what you will do? See, these are what? Rows, or you can say records or tuples. Now if I say, if I want to fetch a record, I want to access a record and the name of the student is A. Now see, name is this one. Now go to the name of the student, that is A. But here also we have A, here also we have A. So which record you will fetch? I am not able to identify uniquely that which record I want, this one or this one, right? Because this student is having, see, marks is also same, department is also same, but course is C1. For this student course is C2, but I am not able to identify with the name. If I say the department, I want to access the record, the one row or one record having department CS. Now this is also CS, this record is also having CS, the department value is CS and CS. Now this is also very confusing, right? So we cannot uniquely identify using department as well, right? So that would be problematic situation. I am not able to access the data in my database, or I am not able to solve my problem. So if I am not able to solve my problem with the data I have, then what's the use of this data? So there should be something using that I can identify each record uniquely. I can access each record whatever I want, right, by giving that particular value. Fine. Like in my class, if I have 2 students, both are having same name, that is Nisha, and I want to ask a question to Nisha. So now if I say, Nisha, please answer this question. Now if there are 2 students, then who is going to answer the question? Then that is a problematic situation, right? So now in my class I have roll numbers of each student. Now suppose I have this roll number of one is 15 and roll number of another is 18. Now if I say roll number 15 answer this question, then obviously that there is no problem. There is only one student who is having roll number 15. So here using roll numbers I can uniquely identify each student in my class. So that is what a key now. Now you know that what is importance of key. Without key I cannot uniquely identify the records. Then what is the use of storing this database, right? Now here also if I take suppose SID, and value of SID is 1 2 3 4 5. Now if I say I want to fetch the record where the SID is 3, means SID is 3, this one. So this is what SID is unique, because here we have 1 2 3 and 4, no 3 SIDs there. Fine. Now I can easily fetch this record, means I am sure that I want to fetch this record. Now according to, if I want to fetch according to SID 1, then definitely I am going to fetch this record. So now using SID, I can uniquely identify each record in this table. This is very small example. I am taking only 5 values, means 5 tuples I have, right? So here you can say SID is key. Fine. Now see, if I say I want to fetch the record where department is CS and course is C1, I am taking these both as one unit, right? Means department is CS and course is C1, CS C1. Now this combination I am going to take, see, this is now our key. See, now this is a key or not? CS and C1. Now see, is there any other combination, same combination? See, here we have, suppose here also I have C1. Let's take this as C1. So now combination of this one, here we have C1, but the value of department is different. So this is not same. Here we have CS, but here the course value is C2. Here we have C1. So this is also different. So see, here we have EE C1, but here we have both. See, E is same, but here we have C3. Here we have C1. So these are also not same. Now this complete, these two we will consider as one unit, right? So this is the combination. Using this combination, I can uniquely identify each record. If I want to fetch that record having department name CS and course is C1, then definitely you will get this row, because this is the combination in this row only. In no other row I have this combination, right? So now you can say this is also a key. Fine. For this relation. Now let us take name and marks. Can you identify each record uniquely using name and marks, right? Both name plus marks. Now this is now a complete unit. Now see, here we have, suppose I am saying name is A. I want to fetch the record where name is A, marks 78. Now check, name is A, marks 78, but here also we have A 78. This combination is at 2 place. So this, you will fetch this tuple or this tuple, we don't know, right? So we cannot uniquely identify using name and marks. So this is not a key. Now see. Now let us suppose in this table I have only these 4 attributes. I don't have SID, and I have taken all the 4 attributes: name, marks, department and course. Can you identify each record using this combination? Yes, this would definitely be a key, because here I am taking the combination of all the attributes in my relation, and that would definitely is going to be identify your each record uniquely. That is for sure, because here in this table that would not be a case that all the 4 attributes are having same value like this one, this and this row. No, that could not be a case in the DBMS, in RDBMS, right? So definitely no 2 tuples or no 2 records can be same, exactly same. Fine. So all the attributes, maybe some attributes may be same, like A78 and CS, A78 CS, 3 attributes are same, but 1 attribute is different, that is C1 and C2. So definitely this would going to be a key, the combination of all the attributes in your relation. So now what is key? Can you define key? See, in key I can have 1 attribute as well. See, suppose here I have SID, then that is single attribute is also a key, and this is also a key. Means a key can be, or you can say key is an attribute or set of attributes that uniquely identify each record in the table, or you can say in the relation. Fine. Now next is types of key. That is, first one is super key. Super key is nothing but it is a key, right? Interchangeably you can use the word key and super key. So here I can say the definition should be same. Super key or key, right? This thing I have discussed, this is, you can also consider it is a super key. So super key is also an attribute, or it can be set of attributes that uniquely identify each record of a relation. So this is simply, you can see, a super key. This rather than key you can write it is a super key. If you take SID here 1, 2, 3, 4, 5, this is also key, as well as you can say it is a super key, right? This is also key as well as super key. So super key is having only one condition, that it should uniquely identify each record of a table. Now it may consider one attribute, and it may consider 2, 3, 4 or all the attributes in a relation. Fine. Now here see, suppose I am taking SID. Now here SID is a super key. Yes, it can uniquely identify each records, right? Now if I take SID with S name, is it a super key, both SID plus S name? Definitely it would be a super key, because if only using the SID, see, let us take one example. See, in my class, using roll number I can identify each student, right? So if I say roll number 15, stand up. So obviously roll number 15, only one person is having roll number 15. Each student is having different roll number. Means I am here considering that roll number is a super key. Using roll number I can identify each student uniquely. Now if I say roll number 15 Nisha, stand up, that is also same thing. Using that thing also, obviously roll number plus name would all definitely identify each student uniquely, if roll number is identifying each student uniquely. So here with super key you can add any attribute and that would definitely a super key, right? So here if I say SID plus marks, that is also a super key, or SID name marks, that is also a super key, right? If SID is a super key. So now question for you is, you need to tell me name, marks, department, is this a super key or not, and marks, course and department, is this a super key or not? You can write down me in the comment box, right? I hope you got the concept of super key. If you got it, then you can easily answer these questions. Now one question may be, now how many maximum number of super keys possible in a relation, right? Now how you will find out this thing, maximum number of super key I am saying. Now for maximum, see, suppose this, let us take this example. In this I have 5 attributes, and in maximum case each attribute individually can be a super key. SID is also, name is also, marks, department, course, means 5 super keys are this one, right? So if I take only one attribute out of 5, 5C1. Now next is, if I take 2 attributes, that is also a super key. Maybe I take SID name, that is super key, SID marks, super key, SID department, super key, name marks, super key, marks department, super key, marks course, super key, this kind of thing, right? So out of 5, C2, any 2 attributes, that is also super key. Now out of 5, any 3 you can choose and that is also super key, plus out of 5 any 4. Now next step, maybe you can choose all 5, 5C5. In that case only one key can be there if you choose all 5, because it's not like that this is one key, SID name, marks, department, course, and another key you can write course, department, marks, name, SID, because in a set I have told you order does not matter. So now here calculate this one. What is this formula? N factorial upon R factorial n minus R factorial, right? I hope you can calculate this one. I am just writing down the value. 5C1 would be 5 plus this would be 10 plus this would be 10. 5 plus 5C5 would be 1. So total it is 31. So here maximum super key possible in this is 31. If attributes are 4, number of attributes are 4, in that case how you will calculate? Sorry, out of 4 you can choose 1, you can choose 2, you can choose 3 plus 5C4. Obviously we cannot write 4C5 because out of 4 I can choose at most 4. So now if you calculate this thing, then you will get 15. So in general, if maybe that question may be asked in, maybe in your Viva or in NET exam or GATE exam, how many super keys are possible in a relation having n attributes? So the answer would be 2 raised to power n minus 1. See, here n is 5 2 raised to power 5, 32 minus 1, that is 31. When n is 4, 2 raised to power 4, 16 minus 1, that is 15. It's not 2 raised to power n minus 1, it's 2 raised to power n then minus 1. So maximum super key possible are 2 raised to power n minus 1, where n is number of attribute in a relation, right? So I hope you got the concept of super keys, and if I give you a table, then you can easily find out the super keys. So let us take one example. Now let us take this relation. 4 attributes are there and this is the value of ABCD. Now total number of super keys possible in this relation, right? In this relation, I am not asking maximum super key possible. I am asking in this relation super keys possible. And which are those super keys? See, I guess you can easily identify A is a super key because 1, 2, 3, 4, 5 the values are not repeated. Using A, I can easily uniquely identify each record, right? Now I have told you, if A is a super key, then if you write A, B, that would also be a super key. Fine, because already A is super key, so if you can combine it with B, then also you can easily identify each record, right? See, if name of two person is different, then name plus date of birth, that is also different, na? Right? But if name is same, both person are having same name, then name plus date of birth, that is not sure that that would be a super key, right? So now I guess AC is also a super key. AD. So these are all super keys, right? I have combined A with all these. Simple A, then 2 attributes, then 3 attributes, then all the 4 attributes. Then all these are super keys, right? Here ACD, you cannot write ADC. This is also another super key because order does not matter. Now, second, is B uniquely identify each record? No, B is having same values. Is C uniquely identify? Is C is a super key? No. Is D is a super key? No. Is B, C a super key? C, combination of B and C. Here we have 1, 7, here also we have 1, 7. So this is not a super key. Now, it's better you find out the combination of B, C, D. Is this a super key? Check. The combination of all the 3, 1, 5, 1. But here see, we have 1, 7, 1, and in second row also we have 1, 7, 1. So we cannot uniquely identify these records with the combination of B, C, D. So if the complete BCD is not a super key, it is not a super key. Then subset of this cannot be a super key. Means only BC cannot be a super key, only CD cannot be a super key. Suppose if name of a person, the same example, if the student is 3 attributes I am taking, name is Nisha, CS department and from Gurgaon. But I have 2 Nisha who are in CS department and from Gurgaon. So I cannot uniquely identify the records. Now if simply I say Nisha CS, definitely that is not going to identify uniquely. That is not a super key. If I say Nisha Gurgaon, that also cannot identify the records, or you can say that person uniquely, right? So no need to check out further if BCD is not a super key. Now here the total number of super keys are 8 in this relation, right? The answer is not 2 raised to power n minus 1. In this relation it is 8, right? I hope now you can easily find out the number of super keys in a relation. Now we will discuss candidate keys. And one more point about super key. Super key is a theoretical concept. We are not going to implement it in any database. It is just a theoretical concept, right? Now next is candidate key. So candidate key is a super key whose proper subset is not a super key, or you can call it as a minimal super key. Now with the help of this example, I will discuss what is meaning of this line, that whose proper subset, what is meaning of proper set, what is meaning of minimal super key. See, here in this case, obviously candidate key is a super key. Now find out super keys in this relation. Now see, A is super key because using A I can easily identify each record. Now if A is super key, then AB, AC, ABC would be super key, right? That is for sure, because here we have A in all these sets. Now check if BC is super key. Only B is a super key? No. Only C? No. check BC, it is a super key or not. Combination of B and C, 1 1, it is not repeated. 1 2, it is also not repeated. Here we have 2, here we have 1 but this is changed, here we have 2 but this is now 2. So yes, BC is a super key. Using the combination of both the attributes, I can easily identify each record. So now total number of super keys are 5 in this relation, right? Now check, a super key whose proper subset is not a super key. Now what does this proper subset means? See, first of all, if I say set 1 is 1 2 3, set 2 is 1 2. If I ask you if set 2 is subset of S1, subset means all the members of S2 should be, or you can say must be, members of S1. Now members of S2 is 1 2. Now 1 2 should present in S1, that is present, so this is true. This is what? Subset. If I say this one, now S2 is subset of S1. Now check the members of S2, 1 2 3. 1 2 3 should be present in S1. Yes, these are present, so this is what? Subset. Now what is proper subset? See, proper subset we will write down like this, and this is what? Subset, right, with one underline. Now is S2 here proper subset of S1? It means, see, if S2 is proper subset of S1, it means S2 is first of all subset of S1, but S1 is not subset of S2. This should be a case. Now here check, is S2 proper subset of S1? First of all, S2, for this condition, these two conditions should be satisfied, must be satisfied, you can say. S2 is subset of S1 means S2 having members 1 and 2, and 1 and 2 are members of S1, so this condition is true in this case. Now check, is S1 subset of S2? This should not be a case here in proper subset. Now S1, the members of S1, 1 2 3 means 1 2 3, are 1 2 3 present in S2? No, it means this is also true. S1 is not subset of S2, but here S2 is subset of S1. So here you can say, now S2 is proper subset of S1. I hope you got my point. Now see, if I take here also 1 2 3. Now check, if S2 is proper subset of S1, check these conditions are satisfied or not. S2 should be, first of all, S2 should be subset of S1, means all the members of S2 should present in S1. Members of S2, 1 2 3, these are present in S1, so this condition is true. But here S1 should not be a subset of S2, means all the members of S1 should not be present in S2. Now members of S1, 1 2 3, but 1 2 3 are present in S2, so now this is not satisfied in this case. Now here you cannot say that S2 is proper subset of S1. I hope you got what is meaning of proper subset now. Fine. Now see, if I take here ABC, ABC is a super key. Yes. Check if it is a candidate key or not. First of all, find out, check the proper subset of this ABC. Here proper subset means, see here, if here we have 1 2, it means S2 is now proper subset of S1, right? If I have only 1, that is also proper subset of S1, but if I have 1 2 3 here, then that is not proper subset of S1, right? It means in proper subset we have one, means less elements than that subset, maybe 1 element less or 2 element less or something like this, right? We cannot say that 1 2 3 is proper subset of this one, but you can say 1 2 is a proper subset, 2 3 is proper subset, 1 is proper subset, right? This is the case. Now here the proper subset of ABC can be AB, BC or AC, right? As well as A, B and C. ABC cannot be proper subset, right? In proper subset, when we have less elements than that set, maybe 1 less element, 2 less elements, something like this, right? Now check whether the proper subset are super key or not. See, AB is super key, AC is also super key, A is also super key. So this cannot be a candidate key. The condition is super key whose proper subset is not a super key. But here proper subset is a super key. AB also, AC also, A also, right? Or maybe only one proper subset is a super key, that in that case also this would not be a super key, right? Now see, check AC. Is AC is super key? Yes. Is AC a candidate key? Now proper subset of AC is what? A and C. Individually, one is A, one is C. AC we can't take in proper subset, right? Now here proper subset A is super key, so this cannot be a candidate key. Now check, is A is super key? Proper subset of this A, it is having only one attribute. If you remove this one, then obviously that would be empty, and empty set of attributes cannot be a super key, right? So no proper subset of A is a super key. So now A is a candidate key, right? Now check for BC. BC is a super key. Proper subset of BC is what? Proper subset of BC is what? One is B and one is C. Two proper subset are there. We cannot say BC, right? Now check whether B is a super key. No. C is a super key. No. So none of its proper subset is a super key. So now this is also candidate key, right? Out of these, for this relation, super key is this one and candidate keys are A and BC. Two are candidate keys, right? Now you got how to calculate the candidate keys out of all the super keys. Now why I am saying it is a minimal super key? It is not minimum super key, it is minimal super key. There is a lot of difference between minimum and minimal. See, minimal means as minimum as possible, right? See, let us take one example. I am taking ABC. This is a super key, right? Complete super key. Now can I discard one attribute or two attributes from this key and still that would be a super key? Yes, that is true. I can discard C and suppose AB. AB is still a super key, right? You can say. Again, can you discard any attribute from AB? Yes, I can discard B and left is A, and A is still a super key, right? Now can you discard from A? No. If you will discard A, then you will left with empty set, and empty set of attribute cannot be a super key. So now this is what? Minimal super key, as minimum as possible, right? Same, let us take example of BC. Can you this is a super key, can you discard any attribute? If I discard B, then only C is left. Is C a super key? No, so we cannot discard B. If you discard C, then only B is there. Is B a super key? No. So we cannot discard any attribute from this, right? So this is what? Minimal super key. So now BC is also a candidate key, right? Minimum means it's not like that the super key which is having minimum number of attribute, that would be a candidate key. No, that is not always true, right? Because see, here A is having minimum number of attribute, but BC is also a candidate key. Although A is a candidate key, but BC is also a candidate key. So we cannot say minimum super key. Here you should say minimal super key. You can say candidate key is a minimal super key. Now here can we say every candidate key is a super key? Yes, but every super key need not be a candidate key, right? So you can draw it something like this. Here we have candidate key and here we have super key. Every candidate key is a super key, but it's not true that every super key is a candidate key. There are some super keys which are not candidate key. You can check out here. Super keys are 5, but candidate key is only 2. Now can you tell me in this relation which is candidate key? See, let us take this super key. Now proper subset of this is what? It can be ABC, BCD, ACD, but ABCD is not a proper subset. Now let us take, I am taking ABC. Now check, ABC is a super key? Yes, ABC is a super key. If only one proper subset is a super key, then that key, that super key cannot be a candidate key. It's not like that all the subsets should be a super key. Now, this is not, suppose I am taking this one, ABD. Now, for this proper subset may be AB. AB is a super key, or you can say BD. BD is not a super key, but AB is a super key, right? If only one proper subset is a super key, then also this cannot be a candidate key. Now I am taking suppose AD. Proper subset may be one is A, one is D. Now A is super key, so this cannot be a candidate key. Like AB, here also A is a super key. AC, here also A is a super key. Now this is not a super key. Now out of this, so now let us take this A. Proper subset may be, obviously if you discard this A, then that would be empty, and empty set of attribute cannot be a super key. So definitely A is a candidate key here. In this case, the candidate key is one only, that is A. Now next is primary key. Now what is primary key? It is very simple. One candidate key out of all the available would be set as a primary key, right? And second condition is what? One candidate key with no null values. That would be selected as a primary key, and remaining candidate key would be considered as alternate keys or secondary keys, you can say, right? So one candidate key that have no null value. The constraint on primary key is what? It shouldn't have any null value, right? That will be selected as primary key, and remaining candidate key would be selected as alternate keys or secondary keys, right? So from here, in this relation, candidate keys are A and BC. So we can select as A as a primary key, or you can select BC as a primary key. It's not like that. In primary key we have only one attribute. See, primary key is what? Primary key is candidate key. On candidate key, do we have any constraint that in candidate key we can have only one attribute? No. So that is why on primary key also we don't have any constraint that in primary key there should be only one attribute. From here, in this relation, if I feel that in A I can have null values, so I can consider BC as a primary key, right? So now here, if I consider A as a primary key, so now A is primary key and secondary keys are BC, or you can say alternate key is BC only, fine. So now here you can say every relation can have more than one super key as well as more than one candidate key, but primary key must be only one, right? So I hope you got the concept of super key, primary key and candidate key. All these keys we are going to use in normalization, right? Foreign key we will discuss later. First of all, we will discuss normalization and functional dependencies. So you should know the concept of these keys, right? Now we are going to wrap up this one with the help of one example. Now this is the question for you. Suppose in a relation I have three attributes A, B, C, right? A is a candidate key, it is given, right? A is candidate key. Now you have to find out number of super keys. Now here you cannot say 2 raised to power n minus 1, right? I am not asking about maximum super keys. Out of given information you have to find out SK. Using that information you have to find out number of super key. Now given is, this is very important. Now A is candidate key. Now if A is candidate key, then obviously that is a super key, right? Because we select candidate key from the super keys only, right? Because you can say every candidate key is a super key. So now first is A. A would be a super key. If A is super key, then I can combine it with any other attribute and that would definitely be a super key. So AB is also super key, AC is also super key, and ABC is also super key, right? Now, is B a super key? No, because if B is a super key, then here I must have given that B is a candidate key, and that information is not available with us. I cannot say B is a super key or BC is a super key or C is a super key. So out of this information available, I can say that number of super keys are 4 for this relation. Now suppose it is given relation is this one and AC is candidate key. Now A is not candidate key. Question 2 is AC is candidate key. AC, both AC. Now find out super keys. Now definitely AC would be a super key, right? And if I combine AC with B, then that would also be a super key. Can I say A is a super key? No, that I cannot say, because AC is candidate key, not A is a candidate key. So I cannot say that A would be a super key. From this information that is given, super key can be AC and ACB now, or you can say ABC. 2 candidate key. Here we have 4 candidate key. Now this is question for you. Relation is having 4 attributes ABCD. Given is A is candidate key and D is candidate key. Now you have to find out the super keys. How many super keys and what are those super keys? You can write me down in the comment box, right? So now in the next video we will discuss what is functional dependency, and after that we will discuss normalization. So now I'll see you in the next video. Till then, bye bye, take care.